Come to Wapoma. Jack 11, it's a 9 or 8.
E5.
It's a 9, eh? Then if you say 9, Jack 8, 12. It's 8. Again? Because they combine theorem 1 and 2 from grade 11, combine them to be 1 or grade 12. Okay?
Yes.
Now, if you remember, up to the last one. We're moving together more, okay? Now, I'm going to write down the theorems so that in future, any question that comes from Euclidean geometry, there is always a theorem. But before I go to the theorems, I want to talk about the transversal lines. Are we clear? The what? Transversal lines. When I talked about the lines that are within the rectangle and the triangle and the rhombus, again, say that the lines are parallel, the lines are equal. Are we clear? When I say that this is a line and then a line has a point like 1, it means, or if there's any other line somewhere has a point like 1, it means the two lines wherever they are what? Equal. They are equal. Now in Euclidean geometry, they are not necessarily in a shape that you are used to. Like a shape like a rectangle or a triangle or a square or any shape. They can just be a line on a circle. Are we clear? Those lines in a circle, we call them the chord. We call them what? The chord. Now remember when we were doing the analytic, we said now we are having a circle like this. Again? Now if a circle has a center, now in Euclidean, it's not necessary for the circle to have what? Center. Center is not what? Necessary. But if you have a center, you are popping. Yeah? So now we're talking about what? The chord. What is a chord? A chord is a line drawn from one point of a circle, straight line from another point of a circle. Are we together? Yeah. So this line now, if it's here is A, here is B, it means now AB is a what? It's a chord. When you check a chord, when they say a chord, they're talking about the line on a circle touching one end of a circle to another. And that line, it has to be only what? The straight line. Yes. Now if I draw this line and then I put one here and then I draw another line somewhere here, now it's C and D, and then I also put the point here. You see now these two lines, they don't give or they don't form or they're not falling in any shape that we used to know, which is a square, rectangle, rhombus, parallelogram and whatsoever. Are we clear?
Yes.
But the two lines are separate, which means we call them what? They are now two chords. And if they're having this point on the line, it means, or remember, the one represents that the lines are what?
Equal.
Are equal. So in other words, it means the line AB is equal to line CD. So be careful of these things in any way. So we know what to do with the equal lines. So there are the theorems that will tell us if the two lines are equal and therefore what happening with the angles. So specifically the Euclidean, we are looking at the angles. We are similarizing or we are equating the angles that are the same and that are also equal. We are using those lines and then to check how many angles are equal. Coming back to the transversal lines, now we're talking about the two lines that are crossing each other. If the two lines are crossing each other, forming the shape of what? The shape of X. Are we clear? Now we say that these lines are vertically what?
Opposite.
They are vertically what?
Opposite.
Vertically opposite. The two lines are vertically opposite. Now the simple way of writing vertically opposite is just VERT dot op. Wherever in future you see VET op. In our way, vertically what? Opposite. So now here we are having a 4 angles. Angle number A, angle number B, angle number C, angle number D. And we know an angle that form a round or angle in a circle, they are revolution. They are equals what? 360. So which means when we add angle A plus angle B plus angle C plus angle D, all of these angles, they add up to what? 360. So now when we see the shape of X, we say that angle A is equal to angle C. Reason will be what? The angles are vertically what? They are vertically opposite because the two lines form angle, they form shape man. X. Are we clear? We are together, Mus. Yes. Then again, angle B is equal to angle D. Reason, still saying vertically opposite angles. So in something like this one, you will still see the shape crossing, making the shape of an X. And if you familiarize the angles there, they are looking for them. Then you just do with the reason. Now when coming to Euclidean geometry, you don't just say one angle is equal to the other angle without giving us a reason. So in other words, there should be the statement and a reason. So if you only have a statement without the reason, your answer is not complete and is not correct. So be careful. If you know how to reason. Other lines that we will be talking about here, we are talking about the lines that we will call them two lines that are parallel. The two lines that are what? Parallel. Now if the two lines are parallel, they are now cut by a straight line. They are cut by what?
A straight line.
That will give us angle A, B, C, D, angle E, F, G, H. And what? H. So now if we have something like this one, there are three shapes that we can take out here. Shape number one is shape F. F here this line are parallel like this. Again? The second one is shape Z. Are we clear? Z there na yo baga kono. Line continuous. Right, bottom U is this line. The last one being U. Again? Z and N is the same shape. Are we clear? It's what? Same shape. Just that we can pendulum it to this way. Z there can pendulum so about N. Are we clear? Now let's look at Z. So at F. F where the angles that are equal is this angle and this angle. Now since I have a reference on my statement, I'm having what? A reference. So which angles are here that we see? Angle number
D and F.
Angle number D is equal to angle A. Then will be what?
Corresponding
angles. Are we clear? Sign angle. This is not L. It's less than. It's what?
Less than.
So S here routing plural again. Corresponding. Corresponding. So the two angles are equal by correct. Are we clear? Now, the same shape here F, it can be looking anywhere of the choice. The same shape here F, it can be looking downwards like this. Are we clear? Now, if it's like this one, which one would it be?
F and B.
F and B. Is A and what?
And G.
A and man? A and E. Again? You. Again. Then reason corresponding angle. There are so many F's that you can find here. Again. Are we clear? There are so many that you can find. You will still find it. Yo. Hey, Leo. Again. Good. Now let's go for Z. Z angles are alternating. Are what?
Alternating.
Sorry?
Alternating.
Alternating. So it can be shape Z or it can be shape N in any form. Now here is angle U and this angle. The angle mamuga shape.
C and F.
C and
F. D and
two.
E.
D and E. Again. D is equal to angle man. E. Are we clear? Reason are alternating angles. Alternating man. Angles.
C and F.
Alternating man.
Angles.
Angles. Let's look for, we can look for this shape in many ways. Are we clear? So just be careful. The first thing you see or you notice that the lines are like this, giving you this shape, draw it separately and equate the angles. Are we clear? Shape U. Shape U, come here, bang.
D and F.
Angle here, angle here. Yo, bang.
D and F.
D and man. So now what angle D plus angle F equals to 180. Exactly, they are not what? Equal. They are not equal. They are equals to what? 180 when we add two of the angles. Reason, we say that the angles are co-interior. Co-interior man. Angles. Reason. Right, bottoms? They are what? Co-interior angles. This is the important part. I'm telling you. You know what I'm saying is the important part? Yes. There's no way they are going to teach you. If your teachers are still teaching you grade 11, grade 12, you are right. If they don't, that's where they want you. These things you must learn them from grade 8, 9. How can I teach you? So if they are teaching you these things, you are lucky. What they should be doing on grade 11 and grade 12, it is just to the theorem. Now the lucky part for those theorems, they are having this type of lines. And they are talking about the angles. And if you can notice them, you cannot solve a theorem without noticing these things. Because some of these things, they relate you to show that the theorems, the way they want angles equal or the sides equal, is because of these properties. Yeah, bad. Good. Let's find the relationship between the angles. You said that when I write, you write. Okay, now they are the angles that when we see them, the angles in a line, number one, angles that are complementary, are what?
Complementary.
You and your crush are complementary.
Yes,
What?
we are.
You are complementary. When we say angles are complementary, let's talk about angle A and angle B. Again, so we talk about angle A and angle B in a 90-degree triangle, which is a right angle triangle. Are we clear? So we'll have angle A and angle B. Again, so which means the complementary part will say angle A plus angle B. They are equal to 90 degree. Again, reason will say complementary angles. So complementary angles, we can find them if they are what? The two lines perpendicular. Are we clear? Not always a right angle triangle. Be careful. When they say the two lines are perpendicular, again, then you can form a triangle there, and then you have a right angle, then angle you, angle 90. We know that the sum of the angles in the triangle, interior of them, 180 again. So we'll have 90 plus this angle plus this angle. So 90 plus 90, it's 180. So which means if we have the first 90, the second 90 will be this one and this one. Are we clear? Good. Number two, we are having the supplementary angle. The what?
Supplementary.
Supplementary
Add up to 180.
angles. So if now it's the same angles like this one. Now these two angles, they are not in a triangle. They are not in a what?
Triangle.
We have a straight line. Remember the angle in a straight line is what? It's 180. Now we have a straight line like this one, but then now the line cut. It can continue like this one. Again? And sorry, I will probably reach a vertically opposite. Again? But then I give you this more, it can continue like that. Then you have one angle A come, one angle B come. As long as this line A and line B is a straight, as long as it's a what? Straight line. Be careful because sometimes it's not a straight line and you cannot use these properties. It has to be a straight line. Are we clear? So once it's a straight line, we can conclude saying that angle at A, which is A, and angle B, they are equal to 180. Are we clear? So if it's 180, reason, we will say they are what? Sub angles. Simply so. Again, supplementary angles. Are we clear? I think I have some of them.
Yes.